All right, so we're on the backside of day 3 notes, and we're talking about the cross section of a cylinder. Remember, a cross section is a slice. So if you were to slice this with a knife, there's different ways and directions you can slice something, all right? But when we pull the shape apart after we slice it, the two-dimensional shape that you see is called the cross section, okay? Remember, cross sections can be horizontal, vertical, or diagonal, and a cross section that is parallel to the base. Okay, so if I take my knife and I slice this cylinder parallel to the base, okay, and I pull it apart, I'm going to go ahead and see a circle on the top part of the cylinder and the bottom where I sliced it. So a circle is possible cross section of a cylinder. Okay, now if I were to go ahead and take my knife and instead of slicing it parallel to the base, and I slice it what they call perpendicular to the base, which is a vertical slice. So I take my knife, okay, and I slice it downward, and I pull the left side away from the right side of the cylinder after I slice it. The shape you're going to see is actually a rectangle. All right. And those are the two you should be familiar with: parallel to the base and perpendicular to the base. Now, there's other ways to slice a cylinder. If I were to slice my cylinder at a diagonal, okay, so if I take my knife and I slice it this way, I didn't mean to be such a thick line, okay, but you get the point, I think. You guys would go ahead and see more of an oval shape. The pen is still too big, okay, and so it'll look something like this. Okay. And that's called an oval, or the fancy word is an ellipse. Okay. Now, if you go and you slice it, let's see. If I erase this and I slice it, notice that slice didn't go right to the base of my cylinder, but if I slice it, let's say down here where I go through the base, this part will be the oval part, okay? But this will be straight on the bottom, and it'll almost look like this, okay? This part, because it's curved there, but straight here, that's actually called a parabola, which you guys saw last year in algebra. Okay, so now they asked me a multiple choice question. So let's go ahead and read it and see what the cross section will be. It says Jennifer is trying to determine if there's any difference in shape for various horizontal cross sections of a cylinder. Jennifer takes a cross section of the cylinder that is parallel to the base. Next, she takes a cross section that is slanted 5 degrees from parallel and doesn't intersect the base. What were her results? So let's go ahead and draw two cylinders, because she's slicing it two different ways. Okay, so the first slice, okay, she takes a cross section of a cylinder that is parallel to the base. So she takes her knife and she slices and cuts the cylinder there, which is parallel to the base. And what she's going to see is that she's going to see the same circle when she pulls the top part of the cylinder away from the bottom part. All right, and so she's going to see that nice circle there. All right, so this will give you a circle, just like we talked about right up here. Okay. Then she says she takes a second cross section that is slanted 5 degrees from parallel. So it could be something like this, okay, where she slices at an angle, okay, which is not parallel to the base, obviously, so 5 degrees. When she does that, she's going to end up with this situation where she gets an ellipse. Okay, so what were her results? The cross sections were both circles. No, they only come out both circles if they're both parallel to the base. The cross sections were both ellipses. No, the first one was a circle because it was parallel. The second one is an ellipse, so no. Choice 3, the first cross section was a circle. Yes. The second cross section was an ellipse. Yes. I think it's choice 3, but I'm going to read choice 4. The first cross section was an ellipse. No, I'm pretty sure that when she took her first cross section, it was parallel, so the first one's a circle, and so choice 4 is out, and it's number 3. All right. We also have to talk about rotating a rectangle around one of its sides to create a cylinder. So this is almost like rotating that cross section, okay, actually only part of the cross section around what they call an axis, okay, or this line here that's in the middle. If you were to take, I always think of like a flag on a pole on a windy day. All right, that's what I always imagine. So like this is the pole the flag is attached to. Okay, and here's your flag on that pole. And if it's really windy, a lot of times the flag will blow around and around and around and around. And not only the top goes around, the bottom does too. And by doing that, you can see in the next picture that if this rectangle were to go around, it creates kind of that cylinder. You see that? So anytime that you rotate a rectangle around one of its sides, it creates a cylinder. But what we have to be careful about is rotating around a different side will create a cylinder with different dimensions, thus a different volume. All right. And so in number 5, let's see how they do this example. It says that a rectangle whose length and width are 10 and 6 respectively is shown below. Okay. Find the volume of the solid that is formed by continuously rotating the rectangle around its short side. Okay, so what that means is that this is the pole this flag is going to be rotated around is on the short side of 6. Okay, so there's the pole the flag is attached to. When this flag rotates around, okay, it's going to create a cylinder that kind of looks like that. Okay, so sometimes it's easier to redraw our picture. And so what you can see here is that that 10 is actually the radius of the base, and that 6 is the height of your cylinder. Okay. And now we can go ahead and find the volume of our cylinder. So first thing is we had to know it's a cylinder, that the rectangle rotating around, okay, makes a cylinder. Then we have to realize they're talking about volume. So volume of a cylinder is pi r squared h, like we were using on the front side. They want to know the volume, so we'll leave that open. We'll leave pi. The radius, we said when this rotates around this way, is 10. Formula says to square it. And then the height is the 6. Okay. If you notice, guys, in part A here, they didn't give us any rounding directions. And if we put pi in the calculator, it's going to give us a decimal that we're going to be tempted to round. So we're going to keep pi here. We're going to type all this in instead. All right. So 10 squared is 100 times 6 is 600. And so our volume will be 600. Pi didn't go in the calculator, so it's right next to our 600. So 600 pi. And there's no units, but we can say units cubed because this is a volume, and there's the volume of our cylinder. Okay. Now part B says find the volume of the solid that's formed by continuously rotating the rectangle around its long side. So what I'm going to do is I'm going to redraw that rectangle that's in here that has dimensions of 6 and 10. But now what they're saying is that it's rotating around its long side. So the pole here is on the long side and the flag is rotating around that 10, which is the longer side. And so the flag would rotate this way now. Okay. And the flag would go around and around and around. And our cylinder would look something like that instead. Okay. So I'm just going to real quick redraw that. And so you guys can see that this here is 10 and this here is 6. And so now 6 becomes my radius of the base and 10 is actually my height. And so remember with cylinders, you got to stand those straight up and down so that they're sitting on a circle. And so that's why the circle on the bottom there has the radius of 6. And then if you stand it up, the height is 10. All right. So again, it still forms a cylinder. So our volume formula is still pi r squared h. Again, we're trying to find the volume, so we'll leave that open. We'll leave pi here. And then our radius is actually now the 6. Make sure you square it. And then the height is actually 10. Again, I don't think I saw any rounding directions in this one, so we're going to leave pi on our paper, and we'll type in 6 squared times 10, or 36 times 10. And that's going to give us 360. Pi did not go in our calculator, so pi is right next to the 360. There's no units, so we'll say units cubed because this is a volume. And there is the volume of our cylinder. So you guys can see, depending on which way the flag or the rectangle is rotating around which side gives you a different volume. So we can have the same dimensions of the rectangle, but depending on which way it goes, gives us different volumes. All right. So be careful on which way it tells you to rotate your shape around. Okay. All right. Great job. And I'll see you guys on day 4.